This conference will now be recorded.
This conference will now be recorded. Right, so we have covered so far about the list and its implemented classes. Okay, we discussed as part of this array list, linked list, and vector. Right, and then we also discussed about the cursors. Cursors, when I say cursor, just that helps to move to get over through the elements one by one. We have different kind of cursors again. We have iterator, list iterator, and enumeration. Right, these are the three things. So iterator is a global collection level iterator. So you can use this iterator to iterate through a list, or through a vector, or through a linked list, or anything. And list iterator is specific to list implementations, meaning that so iterator can helps to iterate through set also. Okay, but this is specific to list implementations only. You can use list iterator for iterate through this. And enumeration is only applicable for vector. So this is a legacy cursor, okay, which is introduced in 1.0. All right, iterator is a generic one. List iterator is specific to the list implementations, and enumeration is specific to vector. Okay, so we know already we have a collection, which is a root interface. Collection is a root interface, and this collection interface is extended by iterator interface. So that is the reason you can use this iterator on any collection. So when you see collection implementations, we have list is one interface, and also we have set interface collection. So we have list interface as well as set interface. We have iterator. Iterator is the interface which collection is extending. Okay, so collection is extended by list and set, of course queue also. Let's talk about that later. So now we already discussed about the list. Let's understand about the set. All right, okay, so set, when you look at the set, so set has different implementations. Okay, set has different implementations. We have something called HashSet. Okay, HashSet. There are something called tree set, and in between there is one more interface introduced, sorted set. Okay, we'll discuss about that too after after the discussion of HashSet. Okay, set is implemented by HashSet. HashSet is a class. Okay, let us understand that. So here I'm taking an example of set HashSet. Okay, so this is all these classes are available from what? Java.util package. Classes are interfaces. So set s is equal to new hash set. Now let us understand the source code of hash set. Go there, hash set. Okay, it is internally using a map concept. Hash set is internally using a map concept, hash map concept, to organize its data. But a hash map is a different family altogether. Hash map, the specialty of a map, a hash map, is to store the data as a key value pairs, whereas a set is just an element. It doesn't have a key value pairs to store. But why internally it is using map is the question. Okay, I will answer this once we are comfortable understanding the hash map. We'll come back, we'll revisit that, and we'll discuss. Okay, so this is the hash set class. So class has set, it is extending what abstract set. So for class also we have abstract for list also we have abstract list, if you remember. For set also we have abstract set, and then extended it is extended by abstract set and implemented by set interface. Set is the interface, clonable, serializable. So clonable is to support or to allow to clone the hash set object, and serializable is to allow to send the hash set object across the network from one server to another server. Is a serialization concept. Okay, so it supports all of them, right? And when it is introduced in 1.2 itself, in 1.2 itself. So, and what are the constructors it has? Hash set of, if you see empty constructor, okay, empty, it creates empty set, and it accepts a collection says you can pass it a array list object, you can pass a vector object, you can pass a linked list object. With that set of elements you can create a hash set. Okay, so there are few more other constructors as well. This decides like this, it is about the capacity. So we understand in case of array list or vector, initial size or capacity is like 10, and then after it increases its capacity once it has reached its size. So you added 10 elements and you are going to add 11th element, then it resizes its capacity. In the similar way, so here in this case there is a concept of load factor. With the help of load factor, this hash map hash set is going to reconstruct. Okay, it's going to reconstruct. So internally it is using hash map, so that's what I'm saying, that load factor concept, the load factor concept, it's going to restructure the map and arranges the elements in the set. Okay, so hash set of initial capacity and load factor and just initial capacity, meaning that while creating a new hash set, okay, I wanted to create 100 elements, then you specify the 100 as a capacity. Okay, once after it reaches its capacity, it will resize it automatically based on the default load factor. Okay, based on the default load factor. So that's what. No, I don't want to go by default load factor. I wanted to give my load factor, so then you can use this constructor. Okay, all right. So right, so let me load factor. So somewhere that will be specified the load factor. In general, the load factor should be in between 0 to 1. So we'll have to give the load factor range in between 0 to 1, meaning 0 0.1, 0 0.2, 0 0.7, like that. The default is 0 0.7. Should see in the hash map, I believe. Okay, we'll get to know that. Okay, so just come back to this set s is equal to new hash set. Okay, so we have different kind of constructors, right? We'll explore them. And what are the other properties that we have to understand? We have multiple uh, other properties, right? What we have to see is whether my set allows duplicate elements or not. Duplicate elements allowed, and can I insert a null object? Null value is allowed. Is insertion order is preserved, meaning that whatever the order I have added my elements to the set, so can I expect the same order when I'm accessing it? Insertion order preserved. Is it sorted? Is it sorted? Okay, so is it allow different type of objects? Heterogeneous elements. So these are the characteristics, like how it behaves or how it works with respect to all these. Okay, let's understand this one by one. So set, let me add element 100. Okay, I have added one element 100, and again I am adding one more element, say 10. I start add of 20, s dot add of 2, s dot add of again 20. So 20 is the duplicate element, correct? 20 is the duplicate element. So let me print the set object. So I'm just printing the setup. Print of yes. Now tell me, like, is it going to allow the duplicates or not by looking at the output? Okay. Run as so 200, 20, 10. Where is the second 20? Don't see the second 20, right? So meaning that what? Set does not allow duplicate elements. What is the difference between list implementation and set implementation? The primary difference is set does not allow duplicate elements, whereas list implementation allows duplicate elements. So if you wanted to, if you are reading some data from the database and the data might be having some duplicate, but still you wanted to have the duplicates, then go for a list. But you don't want to allow the duplicates, you just wanted to filter out the duplicates, then take the set. Take the set implementation as set. Okay. So duplicate allows or not? No, doesn't allow duplicates. And what about the null values? Okay, can I add a null value to this? Suppose, okay. So I just added a null value and see any exception that we get, or it will add that. Happily it allows. Okay, can I add one more null? Of course you can add, but it simply ignores because it treats that as a duplicate. Okay, so null value is allowed or not? Null value is allowed. And insertion order is preserved, meaning that whatever the order I have inserted, so do I see the same order in the output? No, right? So I have added null at last, but it is giving in the beginning, and then 200, 20, 10. So I have is that the same order that what I have entered? No, right? That is what insertion order is not preserved. No, insertion order is not preserved. Okay, and again, is it going to sort by any chance? It's what, again you see the data, is it in sorted order? No, right? So it's the output is zigzag, so you cannot expect the same order what you have inserted, and also you cannot expect the elements are in sorted order. Okay, this is not sorted. Okay, so this is not sorted. Heterogeneous elements can be added, meaning different kind of elements. S start add of hello. Can I add this? So if I add string, meaning that what I am, so I should be able to add different type of data or not? I can add a null, I can add integer, I can add string, of course I can add other types also. So heterogeneous elements are not. Yes, happily. Okay, you can pass over, you can pass it over. So this is what your set. Okay, so all right, so then I have a list object here, a list, and for my list I am okay, I'm having some other data in my list. Okay, say okay, I have the data in my list. Okay, now so I can use, or I can create my hash set. Okay, I can create my hash set using my list. So I can send this list object to my hash set constructor. That is what the interaction between the collections. So you can create a set object using list object. you can create a list using a set object. So vice versa, you can do anything. Okay, so now what is the output? So my output is going to keep Venkat and Java also along with this data, because while constructing HashSet, it takes the list of data and construct with that by default. Okay, then on top of it you added other things. So Java is there, Venkat is there. Okay, so that is what the constructor. In general we use these kind of constructors. Okay, so if you wanted to create a constructor with the capacity also, you can construct new hash set of so 2 elements. Yes, you can just have, you can it allows to add 2 elements. Okay, okay, now when you try to add the third element, so it restructure its capacity. Okay, it restructure its capacity, but we don't have to worry about that portion. That takes care internally. Okay, that will be taken care internally. So the initial capacity is 2. I have added 2 elements, but still I'm trying to add one more element. So then the capacity is going to restructure, and the capacity is going to restructure, but still it allows the all 3 elements. It allows all 3 elements. Okay, all right. Hmm. All right, so if you see this is going to be initial capacity. Constructs a new empty set. Okay, backing hash map instance, the specified initial capacity, and a default load factor is what, 0.75. This is the default load factor. When it has to restructure, right, so it goes to this one, this particular way. Okay, so it takes this load factor. Okay, so it's going to resize it based on some algorithm. Okay, so this is shift operators. Later you can okay, understand if you want, like not required, but if you wanted to know how it is working, still you can understand. Okay, so it's going to resize the capacity. Basically it's going to resize the capacity, right? So you can use any of the constructors. Okay, why do we need to follow this, the capacity and all? To just save the performance, to save the time, basically to improve the performance. Okay, if you are sure that you will be having you will be getting 100 objects or 200 objects, then you create a hash set initially that much big size initially only one time. If you don't give anything, then it go by default capacity, and once it is reached its capacity, it will resize it. It will resize its capacity. Again it has to resize until it reaches 200 elements. That takes extra time. That's where you can see little performance issue. Okay, okay, so what is our understanding? So we have observed these characteristics, how it works with respect to set, and then so we understand the constructor by taking the another collection. This is what array list here in this case. Okay, and we also have seen the capacity constructor with capacity. If you want to load factor, you can specify the load factor also. If you don't want to go by default load factor, then you can specify your own load factor. So this is, I guess, floating point. So this also you can give your own load factor. Okay, these are the constructors, available constructors. And when it comes to methods, it has more methods. Okay, so just say control O here. You can see the methods. Okay, iterator. This is a this method is overriding method. Okay, this is inherited from super class, super interface collection, and uh, into the collection it is inherited from the iterator interface. So ultimately it is from the iterator interface. Iterator method is, and size to tell like how many elements are there. Capacity is different and the size is different. Capacity is like how many elements you can add, and size is current, like how many elements are there in the set. So is empty, to know whether the set is empty or not, we use this method more frequently. The contains, so if you wanted to verify a particular value is present in the hash set or not, then you can just follow this add remove these methods to add the element and to remove the element from the hash set. So this must be like getting from the super collection. Okay, collection interface. Okay, so this is to add the elements, and the other one is to remove the element from the, and a clear method is to clear everything. So it simply removes all the elements from the set. Okay, there are few more methods, write object and all. These are to support serialization, and clone is to support the clone. Okay, you can clone it. So you can clone it. So write object, read object. These are for serialization purpose. Split iterator. Okay, so these are the methods. So just you can practice by just set a private method or what. So method, clone method, I can call it by okay, just set is interface seems, so it's not allowing it. So you can just have the clone in the object. So if you wanted to clone it, you should use the class only, because clone is available but not available in the set implementation. So s2 is equal to s1 dot clone. This is going to be a set. So throw some exception. This is a checked exception. You should handle that. So clone is going to, I'm sorry, no, it's not going to throw any exception. So then what is the error? Type mismatch cannot convert from object to set. The clone is by default, it is returning as an object. So we just need to cast it. Now print this s2. So s1 and s2 run this. You can see the third object. So this is the clone, exactly the same copy of the s2, right? So I have printed s1, I have printed s2. Okay, so s1, s2 is the cloned object from s1. The cloning is just to create a same copy of that again. So if you wanted to duplicate, so then if you know the object to be removed, you can remove it. using the remove method, then you can print that s. So I should not see 100 in my output. So this is the initial set object, and 100 I have removed. So this you can observe here. So 100 is removed. 100 is removed. All right. Okay. So can I iterate through the set as we have seen in case of list? Of course. But if you wanted to do something, you can call the iterator object on this. Okay. We can iterate through the elements one by one. Okay, so iterate through the elements one by one. It's Java util iterator. Now, so while iterator dot has next, so we has next just print the elements. Okay, or if you want to print, if it is only a particular type, or like you wanted to filter out all the integers, or if you want to filter out strings, or like whatever logic if you want, so you can add the logic over here. Okay, so just I'm printing the next element, and it has next, so you can just print next. This is going to print the set of elements one by one. Okay, here you can see that. So the above print statement prints like this using this bracket, but here I'm iterating through the elements one by one and printing it null java 220 hello Venkatam. So this is printing as part of this iteration process. Okay, you can use this iterator on any collection, not only just list. Okay, set or set implementations, list implementation, and queue implementations. All right. Okay, so the hash set is based on the hashing. Okay, it is not based on the index. The other important notable difference between the list and set is list is index based. Okay, so because the underlying data structures are array global array or linked list, right? Doubly linked list. So you can access list elements using index. You can access list elements using index. Say for example, if I wanted to access this, I can use a simple for loop. Okay, list dot, we have something called size. Okay, so I wanted to add the condition I less than l dot size. Okay, I plus plus. This is what my simple for loop. If I want, I can access the elements using the index. Okay, l dot get of index. I can pass the index over here. So this is what I can access the elements using the index, my list elements. Okay, okay, so can you see here the output? Not this one, still need to go up. So using index Venkat and using index Java, so you should be able to access the list elements using the index because they are index based. So the same thing we cannot, that the same thing cannot be done, same thing cannot be done in case of, okay, in case of set. Okay, if we wanted to do the same thing for set, definitely I cannot do. And I equal to 0, I less than s dot size. Of course I can call size method on set also. I plus plus. Now I wanted to access s dot get off. Do I have any getter method which takes index? No, I don't have. Can I do something like this? No. Okay, I cannot do this. It does not support because set is not index based, it is a hash based. Okay, set is hash based, so you'll have to iterate the set elements using the iterators. Okay, so set is hash based. So what is hash? Okay, well, I'll speak about that hashing. Okay. Mm, okay. So that has a some story. Okay, meaning that it takes 15 minutes to half an hour. But for now, let me just introduce you that. Let me show you what is that. How do we create hash code for our objects? Okay. If you look at the super class, for every Java class there is one common super class. What is that? For every uh, class, so we have a super class. So for example, here I have linked list or array list or whatever it is, a test class, anything, any class. So for any class, so the super class is updated, even though you don't see that extending here, but internally, for every class, internally every class is extended by object class. Every class is extended by object class. Okay, so how to go there is, let's see. uh, okay, any method from object class. Okay, super clone super.clone. So when I say super.clone on that, so it is taking me through to the object class or not. This is what object class, and the clone method is available in the object class. So here it throws clone not supported exception. Okay, so so this is what the super class for each and every Java class. And here I have a method called hashcode method. So here I have a method called hashcode method. Okay, so this is a native method. Hashcode method is a native method, meaning that the implementation is not in Java. The implementation of hashcode is part of other programming languages. So in this case, so this is going to link to the C, that is implemented at C level. Okay, hashcode is going to return a unique hash code number to your object. Okay, meaning that, so when you are adding the elements to the hash set. Okay, when you are adding the elements to the hash set, internally it is working through hash map. Okay, hash map, and it is creating this hash map, and then when you are adding an element to it, so adding an element to the set, so it is trying to place element, okay, in the map using this method. Put value of, can you see here, it's calculating hash value. It is calculating the hash value, hash of key. So this is going to call the key.hashcode. What is this hash code? So this is again coming back to the object class hashcode method. Okay, so this hash code is a native method implementation. What it does is it returns the unique hash code value for the given object. Okay, unique hash code value for the given object. So if you want to know, you can call this hash code method on the objects. Say for example, let me take a string object, string s is equal. What is this? Okay, I would like to take string buffer sb, not string. I'll tell you the reason why not string. So string buffer of hello, string buffer of hello. Then I have sp dot hash code. I can call the hash code method on this. Okay, I'm just going to print this. This is quite important to understand about this hash code mechanism. Okay, run this. What is the hash code value? This is what the hash code value, unique hash code value written for this particular string hello. Okay, now let me take one more object, string buffer object. This is sb1 with the same content hello. I have taken the same content hello. Now, but object reference is different. So now sp1 dot hash code, sp1 dot hash code. So now you can see the hash code value of this is it returns some unique hash code value. But if you observe that for the first time when I run, the hash code value is different, and now when I run, this hash code value is different. Okay, so this is going to return the unique hash code values. This is going to return the unique hash code values, but there is no guarantee that it returns the same value always. It returns the same value always. This hash code returns the same value always. All right, now let me go back and let me check the same thing with the string s is equal to hello. Okay, string s is equal to hello. Let me take string str1 is equal to hello. So I have string and str and str1. Now let me print the hash code values for str.hashcode and str1.hashcode. Print that. Let me run this through. Can you check here? Are the both are returning the same or not? Are they returning the same or not? So run it again. So are they returning the same or not? Run one more time. So are they returning same or not? So that is what. So why this is returning the same value always is because string class, inside the string class, the hashcode method is implemented in Java itself to ensure that always it returns the same value for the given data. Okay, for the given data, to ensure it returns always the same hash code value, we have to implement this in our own way. Okay, so it is when you are working with the customized objects, so it is recommendable to override the hash code method in your class. So suppose you are working with a set of employees, you are working with a set of students, or working with a set of products. So it is highly recommendable to override the hash code method to return the same hash code value for two products. So you have a laptop and laptop, both are same, duplicate things. So in such case, you should tell like, okay, this is a duplicate object. So this is a duplicate object, and it does not allow that. You should not allow that. Okay, it should not allow that. So in such case, you will have to implement the hash code method in your class, okay, to return the unique value for any kind of scenarios, meaning that wherever your application is running, what operating system your application running, when it is running, irrespective of all these things. Okay, so that works well. Okay, that works well. So you understand, inside string class this is overridden, but inside string buffer this is not. So that is the reason it looks for the hashcode method of object class, which is a native method, and the behavior of that depends on the underlying operating system and the other constraints. It's going to return a unique hashcode value, but you cannot expect the same thing always. Okay, so hope you have some basic idea at this point. Okay, so but still we'll have to speak about this hash code more. There is one more method, equals method, hash code and equals method. Equals method also we'll have to override it in our customized objects. So in string class this is implemented, but in string buffer and all it is not implemented. So if you wanted to write your own product class, you will have to implement the hash code and equals method, both of them. There is a contract in between these two methods, so I'll tell you in detail in the next session. Okay, but for now just you have some idea. HashSet is internally using hash map, and it follows HashSet to store and to organize the elements instead of the index. This is not index based, this is hash based. Okay, all right. So it doesn't allow duplicate elements, right? It doesn't allow duplicate elements because on what basis it is going to compare and verify whether it is a duplicate element or not, based on the hash code again. So it is always recommendable to override the hash code method to return the value um, is same for unique objects. Okay, so let me stop it here for today. I will continue tomorrow, discussing more about this. Okay, all right, let me know if you have any questions. Okay.